Hi, my name is JLee, and I am applying for admission into the PhD program. I received my master's degree in Korea, and I have been working as a quant developer in a financial company. My main tasks are managing the C++ simulation engine and developing models. Let me introduce it briefly. I have been updating this since I joined this company in September 2012. When I joined this company, the number of header files was about 60, but now it's more than 130. As it was not made for commercial use, the function is somewhat simple. First, a small pop-up window opens where I can input my ID to login. Then, another pop-up window opens, and this ID will be inputted together with the price into the database. I will press the history button and choose the date, and press the search button to bring up the list of the products that I need to evaluate. And these are brought from the database. Okay, check the boxes and press the evaluation button to input the price in the database. And you can see this. And this process is a little bit slow now because the thread number are set to 2. Now I will explain why I am applying for admission into the PhD program. When I was in the university, it was actually my dream to work as a quant. I know it sounds trite, but I was inspired by Professor Derman's book. I worked really hard to become a quant and eventually became one. But I found that it was different from how Professor Derman described it. The cause might lie in the difference between school and the industry, or the problems of the financial market in Korea. I like learning the theories and programming, but I would like to be given a longer time to solve bigger questions. To be able to do this, it is optimal for me to get into a PhD program. My areas of interest are solving computational and statistical problems in pricing financial products and volatility, interest rate, commodity, and credit modeling. I know these are classic areas, but I believe that they are still lucrative. Let's look at the stochastic volatility model. A good stochastic volatility model has to have realistic future dynamics. But at this time, the term realistic differs depending on the structure of the product. Thus, a perfect model cannot exist because new products are continuously being released. In other words, the potential of this sector is endless. Finally, I'll explain one of my favorite theorems. This is the mean value formula for Laplace's equation. This is a very simple theorem that does not have flash proof, but there's a lesson that can be gained from the theorem itself, which makes us wonder how it was thought of above. Roughly speaking, Laplace's equation is the heat equation with the condition that u sub t is equal to 0. Considering the property of this equation, we can imagine that the solution of this equation must connote such heterostatus. I believe that the person who thought of this predicted the outcome in advance with this factor in mind. I think the process eliciting mathematical outcome with the properties of the object is great. Thank you for your attention. I hope that this video clip will be helpful to the future applicants and admission committee will choose great students.